Still talking about solving logarithmic equations. This next video is about solving logarithmic equations by same base comparison. Same base comparison. In the last video, we talked about solving logarithmic equations by direct conversion. So, solving logarithmic equations by same base comparison, the core principle here is the same base property, right? Uh, if, for instance, you have log f of x to base a equals log g of x to base a, and all the conditions are met that a is greater than 0, a is not equal to 1, all right? It means a can be anything between 0 and 1 and anything bigger than 1, right? Then f of x must be positive, that's greater than 0. G of x must also be greater than 0, both positive. If that is true, then we can compare f of x. We can say f of x is equal to g of x. And this works because logarithmic functions are one-to-one for valid bases. So if you have the same base and you have all these conditions met, then you can easily just compare those arguments and solve for the unknown variable you're looking for. So why the method works, like we said, a logarithmic function with base a greater than 0 and a not equal to 1 is one-to-one. It's a one-to-one mapping. That means that log m to base log m to base a equals log n to base a. If log m to base a is equal to log n to base a, then m is equal to n. This allows us to remove the logarithms once the bases are the same. Okay, so we can remove logarithms once the bases are the same. So we have systematic steps for solving. Step 1, verify that the logarithms have the same base. That's the thing. 2, state domain restrictions by requiring each log argument to be positive. So each log argument has got to be positive. Then 3, equate the arguments. 4, solve the resulting equation. 5, check the solution satisfies the domain restrictions. So here now you're going to have to do like two domain restrictions, and you go for the stronger one if they both agree. But if they don't agree, then there's no point solving for anything, as we're going to see now. So let's see. First example, you want to solve log 2x minus 1 to base 3 equals log x plus 5 to base 3. So what do we do? First thing, check. You want to check uh for same base. Both logarithms have base 3, right? Log 3, log 3. So nice. So we may equate the arguments. That's what that means. But before we go ahead, we have to check for domain restrictions. So for the first one, since log arguments must be positive, 2x minus 1 must be greater than 0. So 2x minus 1 greater than 0 implies that x is greater than half. Then x plus 5 must also be greater than 0. That means that x plus 5 greater than 0 meaning that x is greater than minus 5. So in this case, x must be greater than half. For this case, x must be greater than minus half. So since half is greater than minus 5, then that simply means that x greater than half is the stronger condition. All right. So if you look at the combined restriction, like I just said, so x greater than minus 5 and x greater than half, it means that it goes without saying that that all of that together means x should be greater than half for the whole thing. So let's go ahead and solve. So we can then equate the argument 2x minus 1 here is equal to x plus 5. So you have 2x minus 1 equals x plus 5. Then you can collect like terms. 2x minus x equals 5 plus 1. So that means x is equal to 6. So if you check the domain, since 6 is greater than half, because the stronger restriction is that x should be greater than half. Okay. So, and since 6 is greater than half, the solution is valid. And our final answer here is 6. Okay. And then that takes us to example 2, where we need to solve x minus 3 base 5 equals log 2x minus 9 base 5. Of course, they are the same base. So both logarithms have base 5. So you can easily equate. Then the next thing you want to check will be the domain restrictions. X minus 3 means that x should be greater than 3. Then 2x minus 9 greater than 0 implies that 2x should be greater than 9, meaning that x should be greater than 5. So if you combine x is greater than 3, x is greater than 4.5. So 4.5 is stronger than 3. So the combined restriction is that x should be greater than 4.5. You can then equate the arguments. You have x minus 3 equals 2x minus 9 from here, right? X minus 3 is now 2x minus 9. Okay, then you solve by collecting like terms. So you have minus 3 plus 9, then 2x minus x. That means x is equal to 6. And then if you check, since x since 6 is greater than 4.5, which is the combined restriction, the solution is valid, meaning the final answer again is 6. That is not to say that every time you solve this kind of problem, the answer must be 6. It is just a coincidence that the answer is 6 in these two examples. So example 3 now, you can also have a case where there's no solution at all, as you're going to see in this new case. So here we want to solve example 3, log x minus 4 base 2 equals log 3 minus x to base 2. So they have the same base, so we may equate x minus 4 to 3 minus x, because both logarithms have base 2. But can we check the domain restrictions? First of all, for the first domain, x minus 4 should be greater than 0. That means x is greater than 4. First situation. On the other hand, 3 minus x should also be greater than 0. So 3 minus x greater than 0 means x should be less than 3. So you see we have a problem here. So this one is saying x should be greater than 4, and this one is saying x should be less than 3. Both cannot happen at the same time, right? Both cannot happen at the same time. So it means that these conditions contradict themselves, right? Because this one is saying x is greater than 4, but this is saying x is less than 3. So once they are in opposite directions, then these conditions contradict each other, and there's no value of x that will satisfy both. So the final answer in this case is no solution. So if you check the domain restrictions and the signs are in opposite directions, then the domain it fails the test of domain restriction, and then there will be no answer in that case. So the key takeaways here is that takeaways here include the following: that logarithms must have the same base, all right, for you to be able to solve. Then the logarithm argument must be positive. Of course, we know that. Then you equate the argument, solve the equation. Always check the domain restrictions, because the domain restrictions alone can tell you if the answer is going to fail or not, like we saw in that last example. So it is my time to now solve some of these problems. So here you want to solve each equation, and remember to state the domain restrictions, equate the argument, and check your solution. So from 1 to 10, see what we have. So which one looks the most challenging? 9 and 10 look like they are really challenging. So like I always like to do, I think I need to snip at this time. So let me use the snipping tool. Okay, I'll just snip question. Anyone is good because they look alike. Let me just go for question 10. So do the rectangle snipping for question 10. So with that in place now, I can just copy, then come to the worksheet, and then so coming to the worksheet, I can just paste it here. So right click and paste. All right, so we need to solve for x here. So in this case, so we can equate, equate, we can equate arguments. We can equate arguments since the two logs, since the two logs have the same base, since they both have the same base, we have that. So next, what do? We now need to check for domain restrictions. So domain restrictions now, domain restrictions we now have to be the next. So first off, we have x squared minus 16. So x squared minus 16 should be greater than 0, right? X squared minus 16 should be greater than 0. That means that x squared should be greater than 16. And then that means that x squared should be that means that x rather should be greater than plus or minus yeah, x should be greater than or plus or minus 6, plus or minus 4 when you take the square root of both sides. So this is the first domain restriction. Then on the other hand, we have 5x minus 20. So 5x minus 20 should be greater than 0 also. That means 5x should be greater than 20, and that means that x should be greater than 4. Okay, so looking at all of this now, we have three domain restrictions. So we have combined. So the combined restriction now, combined restriction, combined domain restriction, if you like. So here you have x greater than minus 4, x greater than 4 for this now. And then for this other side, it's also x greater than 4, x greater than 4. So they are all in the same direction. So at the end of the day, x greater than 4, these two are basically the same. So x greater than 4 is the stronger one. So overall, x should be greater than 4. So because this x greater than 4 automatically means x is greater than minus 4. So the overall domain restriction is that x is greater than 4. So with that out of the way, then we can then equate, okay? Equate, equating now, equating both sides. We then have x squared minus 16 equals 5x minus 20, okay? X squared minus 16 equals 5x minus 20. Then we want to solve for x. So we can collect like terms. So we have x squared minus 5x minus 16 plus 20 equals 0. As you can see, so 5x comes here, minus 20 also comes here. So when 5x comes, it becomes negative. Minus 20 comes and it becomes positive. So we have x squared minus 5x minus 16 plus 20 is plus 4 equals 0. Then we can solve now. This is a quadratic equation we can solve. We need two numbers. When multiplied, we get 4. When added, we get minus 5. So clearly, those should be minus 1 and minus 4. So we have x squared minus x squared minus x minus 4x minus x minus 4x is minus 5x. Minus 1 times minus 4 is plus 4. So all of this is equal to 0. So we can group, we have x squared, or we can even factorize straight up, no time. We've done this a lot of times. So x into x minus 1 minus 4 into x, because we are factorizing minus out. So plus becomes negative here. Minus 1 equals 0. And then we have x minus 1 into x minus 4 equals 0. Okay. So in this case now, x is equal to 1 or x is equal to 4. Now, domain, so we now have to take recourse to the domain restriction. So we can then say, since x is not greater, since 1 is not greater than 4 and 4 is also not greater than 4, then there is no solution, and there is no solution. Okay, so if at one of them should have, if this was even if in this 4, if this 4 was like 4.1, it would have been fine, but it is just 4. So we need something. The overall domain restriction says that x should be greater than 4. So now we don't have anything that satisfies that condition. So we have x equals 1, which is not greater than 4. We have x equals 4, which is not greater than 4 also. Okay, then there's no solution. That's all. That's that. We can't, all the solutions 1 and 4 are invalid, and those are the solutions we've got. So let's take questions 11 to 20 and see which one looks the most difficult here. Okay, which one? Yes, I'm tempted to go for, okay, since I've done something quadratic, maybe I should just go for question 20, right? Yeah, that looks like what I should do. So I'll just go for question 20 again. So again, my snipping thing, so I don't have to keep coming back here. So let's snip question 20, and then I copy that and come back here. So I right click and paste. Good. So we need to solve for x right here. So what do we do? Clearly, we can, number one, we can equate arguments. We can equate arguments since the bases are the same. Since the bases are the same. Okay, they're both base 12, so we can equate arguments. That's settled. That's the first thing we want to establish. Second thing is we want to check domain restriction. Check domain restrictions. Check domain restrictions. Okay, so for domain restriction, we have two. We have 6x minus 5 should be greater than 0. And then we also have 3x plus 7 should be greater than 0. 3x plus 7 should be greater than 0. So 6x minus 5 greater than 0 means that 6x should be greater than 5, and then x should be greater than 5 over 6. Divide both sides by 6, right? Then here, 3x should be greater than minus 7. That means x should be greater than minus 7 over 3, right? Well, I mean, they are both greater than, so we are good. So what does that mean? Combined restriction, combined domain restriction, you go for the stronger one. So the combined domain restriction should be that anything greater than minus 7 over 3, if x is greater than 5 over 6, it is automatically greater than minus 7 over 3. So the combined domain restriction is that x should be greater than 5 over 6. So this is the key thing we'll be focusing on. So with all of that out of the way, right? With all of that out of the way, the next thing is to now solve. So we can equate the argument, which is 6x minus 5. So question number 3 now, equate arguments and solve. Equate arguments, equate arguments and solve. All right. So that means we have 6x minus 5 equals 3x plus 7. Okay. 6x minus 5 equals 3x plus 7. 6x minus 5 equals 3x plus 7. All right. So we collect like terms. So we have 6x minus 3x equals 7 plus 5. So that means we have 3x equals 12. And 3x equals 12, right? And that means x is equal to 4. Okay, x is equal to 4. And then the domain restriction is that x should be greater than 5 over 6. So we then go for this that, so what's the conclusion? Conclusion is that since x greater equals 4 is greater than 5 over 6, then 4 is a valid solution. 4 is a valid solution. And that's how we do it, okay? That's how that goes. All right, with that, now we have come to the end of this interesting video about solving logarithmic equations by same base comparison. Don't forget to try your hands on this 20 questions. Okay, I've done 2 out of them. So you want to check 1 to 10, all right, and then check 11 to 20. Let me know how helpful this is for you. And if there's something else you let me try out, feel very free to let me know. If you have subscribed already, I must thank you very much for doing that. If you haven't subscribed, what are you waiting for? Go ahead and subscribe. Hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of this channel by clicking on join. That gives you some special privileges like getting to see some videos first before others, or you might be the only person to see some videos as a member, or you can request for PDF copies of my notes and we can hang out to discuss whatever interests you on my channel. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.